Today's lesson is on whether the fraction is a terminating or repeating decimal. Question A asks you to write 3 different fractions, one with each denominator, out of 10, out of 100, and out of 1,000. The next part of the question asks you, will the decimal representations of these fractions terminate? Explain. How would we turn 5 out of 10 into a decimal? So if the decimal ends after the 5, this is terminating. Is this terminating or repeating? This is terminating. And is this terminating or repeating? So all of these fractions are terminating. What else do we notice about their denominators? What do we call numbers like 10, 100, and 1,000? These are powers of 10, which also mean they are all decimal fractions. Are very easy to turn into decimals because they have a power of 10 on the bottom, so they will always give you a terminating decimal. Question B asks us, why can a terminating decimal always be written as a decimal fraction? So why can these always be written as a decimal fraction? So the place value matches the denominator. So if you looked at 10, well, this would be 3/10, and the 3 is in the tenths place, right? When we have 17 out of 100, it's 17 hundredths, and it ends in the hundredths place. So there's a connection between the place value and the denominator, which is why they can always be changed back and forth. Question C asks you to divide using a calculator and then whether the decimal equivalent of the fraction is terminating or repeating. 5/8 is 0.625. Is that terminating or repeating? So this is terminating. So when we have the repeating sign over any of the numbers at the end, it is a repeating decimal. So because all the digits repeat, this is a repeating decimal. A repeating decimal. So this whole thing is a repeating decimal. Is this a terminating or repeating decimal? Terminating. Okay, the last part of the question asks us to write the fractions with equivalent terminating decimals as decimal fractions. So all of the ones we've put a T at, we're going to rewrite. So if we have, I'm going to do this in red. If we have 5 out of 8, what decimal fraction could we write 0.625 as? 625 out of 1,000, because there's 3 places after the decimal, so we have 3 zeros. What about for question F? 0.0065. As a decimal fraction, this would be 65 out of 10,000, and it's also in the 10,000ths place, right? Tenths, hundredths, thousandths, 10,000ths. That's partially where we get our 10,000ths from. Question D tells us that 10 is 2 times 5. It then asks us to write 10 and 100 and 1,000 as products of 2s and 5s. I'm going to start by dividing things by 2, and I'm going to have a funny format. So I'm going to go 100 divided by 2, so the 2 goes on the left. Underneath, I'm going to put what it equals. So 100 divided by 2 is 50. Then I can still divide it by 2 again. So I'm going to put another box around this one. 50 divided by 2 is 25. Then the 25, I can't divide it by 2, so I'm going to divide it by 5 and 5, which means I could do 2 times 2 times 5 times 5 equals 100. How many, can we divide 1,000 by 2? Yes. 1,000 divided by 2 is 500. Can I divide 500 by 2?
I think so.
Yep, and that gives us 250. Do you want to divide this by 2 or by 5? 5, and that gives me 50. And then do you want to divide this by 2 or by 5? 5, and that gives me 10. And do you want to divide this by 2 or by 5? 2, and that gives me? Oh, close. 5. No, so then we just write all of these numbers out in a list. So I have 2, times 2 times 2 times 5 times 5 times 5. We have equal numbers of 2's and 5's, and that equals 1,000. Question E asks us to write a fraction with the denominator, so that's a bottom number, that's a product of 2's, 5's, or a combination of 2's and 5's. So it could either be all 2 times 2 times 2, or 5 times 5 times 5, or a combination of 2 times 5 times 2 times 5, okay? And then we're going to see with a calculator if the numerator by the denominator gives us a terminating decimal. So what does 2 times 2 times 5 times 5 give me? So this gives me 100, and that's going to become my denominator. Now I just need to choose a random numerator. So I am then going to take my numerator and divide it by my denominator using a calculator. That gives me 0.69, which is a terminating decimal. Question F asks us to write 1/6, 2/6, 3/6, 4/6, and 5/6 in simplest form. Can I divide 1 and 6 by anything? So because I can't divide it by any number other than 1, it is already in simplest terms. Now I'm going to look at 2/6. Can I divide 2 and 6 by any number other than 1? So I can divide them both by 2. So as long as I divide the top and bottom by the same thing, 2 divided by 2 is 1, and 6 divided by 2 is 3. So in simplest terms, this would be 1/3. Can I divide 3 and 6 by any number other than 1? I can divide them both by 3, and 3 divided by 3 is?
That would be half.
1, and 6 divided by 3 is 2, so that would give me 1/2. And this would be it in simplest terms. 4/6. Can I divide 4 and 6 by any number other than 1? I can divide them both by 2, and 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. And so that is our fraction in lowest terms. Can I divide 5 and 6 by any number other than 1? No, I cannot. So this is already in simplest terms. Now the second part of the question asks us, why is 3/6 the only one of the 6 that has a terminating decimal? So because you could multiply 2's and 5's to get a terminating decimal when you had a decimal fraction, this is the only one that could be made up of only 2's or 5's, right? The rest of these would have a different factor in them. You can't just get the bottom number as a multiple of 2 or 5. Step 1 in how to decide if a fraction is terminating or repeating is to write the fraction in lowest terms. And lowest terms means we cannot divide both numbers by anything other than 1. So your second step is to look at the denominator, which is the bottom number. If it can be written as a product or multiplication question of only 2's and or 5's, the decimal will terminate. If you can't make it only 2's and 5's or 5's, then it will repeat. So our first question asks us to calculate the first few powers of 3. So you'd have like 3, 3 squared, 3 cubed, 3 quadrupled. 3 to the power of 1 is just 3. What is 3 to the power of 2 is like 3 times 3, which gives us, Crystal? 27. 3 to the power of 4 is 3 times 3 times 3 times 3. The little top number tells us how many times we multiply it, which gives us, but this would give us 81. Question B asks us if the decimal equivalents of 1/3, 1/9, and 1/27 are repeating decimals. They also asked us how we can tell without calculating the decimal. This will be a repeating decimal because the denominator cannot be made up by multiplying 2's and or 5's. This would be a repeating one as well because of the same situation. We can't multiply 2's and 5's to get 9. We'll face the same scenario with 27 because it's only multiples of 3. We can't get there by multiplying 2's and 5's. The only factor is 3. Question 2a asks us to write the twelfths from 1/12 to 11/12 and then find them in lowest terms. So 1/12 is already in lowest terms because there's nothing other than 1 that I can divide them by. 2/12 I can divide by 2, which would give me 1/6, and this would be my fraction in lowest terms. So I can divide 3 and 12 by 3, which will give me 1/4. So that will be my fraction in lowest term. So I can divide 4/12 by 2, which gives me 2/6. And then I can divide this by 2 again, which gives me 1/3. Now I can't divide them by anything other than 1. So this is my fraction in lowest terms. Make sure you notice if you need to go another step. 5/12 is already in lowest terms because we can't divide 5 and 12 by anything other than 1. So 6/12 I can divide by 3, and that gives me 2/4. So I know I can still get 2/4 smaller. So now I can go back and divide both of those by 2, which gives me 1/2. This is it in lowest terms. I could from the beginning divide by 6, which would also get me the same thing, but it's just a couple more steps, which is fine. 7/12 is in lowest terms because they have no common factors other than 1. So I can divide 8 and 12 by 2, which gives me 4/6. And then I can divide it by 2 one more time, which gives me 2/3. I can divide 9 and 12 by 3. So that gives me 3/4, and there's no more common factors, so that is lowest term. I can divide 10 and 12 by 2 because they're both even numbers, and that gives me 5/6, and there's no more common factors, so that one's already done. 11/12 is already in lowest terms because there are no other common factors. Question B asks me to predict which of the twelfths will terminate, which means I have to look at which of the lowest terms can only be made up of multiples of 2 or 5. So if we have 1/12, we need to look at our multiples or our factors that make up 12. So 12 would be like 2 times 6, and then that could be broken into 2 and 3, and I can't get those any smaller. Even though it has 2's, it also has a 3. So I know this is going to be a repeating decimal because it's not just 2's and 5's, right? So 6, can I divide it by 2? Yes, and that leaves me with 3. This is not just 2's and 5's, right? The 3 means that it will be a repeating decimal. 4 can be divided into 2 and 2. Now this only has 2's and or 5's, so this is a terminating decimal. Now when I look at the 3, I can't break that into anything else other than 1. So this is also a repeating decimal because it's not made of 2's or 5's. We've already figured out that 12 has a factor of 3, which means it will not be a terminating decimal. It will be repeating. 1/2, because the 2 is the denominator, is only 2's or 5's, so this will give us a terminating decimal. 7/12, well, we already know that 12 has a factor of 3, so that's going to be repeating. 2/3, we know that that's a 3, so that's repeating. If we have the fourths, well, a 4 is 2 and 2, so that works. It's only 2's or 5's, so that will be terminating. 6, we've already looked at over here, and it has a 3, so it is repeating. 12ths also has a 3, so that is repeating as well. So our only Terminating decimals are 3/12, which is 1/4, and 6/12, which is 1/2, and 9/12, which is 3/4.